All right, so today we are going to talk about balanced equations, guys. So I call it atom inventory. So what we hope to get out of this is recognize an equation that is balanced and unbalanced. And after that, if it is unbalanced, we are going to balance the equation with coefficients. Okay. So first, I'd like to talk about the Haber process. It's a very important reaction in chemistry. Ammonia is the substance formula NH3. You may be familiar from biology with something called an amino acid, which the root of that word is from this part. It's the amine part of the protein of the amino acid is the NH3 part. Historically, this was a compound that's very important in a few places. Right now, you see ammonia primarily as a household product and used as a cleaning solvent. That's one place where you see it. Other places where it's widely used is for fertilizer and explosives. So, and the historical production of ammonia, it was harvested from guano in caves from where bats live. So guano is poop. So that was gross. So when Haber was able to synthesize ammonia from nitrogen gas and hydrogen gas at high pressures and low temperatures, it made the production of ammonia a lot easier. So this is an important historical reaction. And let's take a look at it. So we have nitrogen, particle of nitrogen, N2, is made of 2 blue circles. Particle of hydrogen, H2, is made of 2 gray circles. And a particle of NH3 is made up of 1 blue circle and 3 gray circles. So you might look at this and notice that there's something wrong with this reaction. And it kind of doesn't obey the law of conservation of matter, conservation of mass. For one reason, in the product side, to the right of the arrow, we have 1 blue circle. And on the reactant side, on the left side, we have 2 blue circles. Similar, on the left side and the reactant side, we have 2 gray circles representing hydrogen. On the right side, we have 3 gray circles representing hydrogen. So what happened here? Did we have a nitrogen atom turn into a hydrogen atom? No, because that would be a nuclear change. That would be a nuclear reaction. This is clearly a chemical change. We have the same elements. So let's talk about how we can make sense out of this. So first off, let's take a look at what makes this an unbalanced equation. So on our reactant side, we have 2 N atoms and 2 H atoms. The 2 N atoms and the 2 H atoms. On the product side, we have 1 N atom and 3 H atoms in that particle of ammonia. So that's why it is not a balanced equation, because we have different amounts of each atom, each type of atom, on both sides of the equation. 2 N atoms on the left, 1 on the right. 2 H atoms on the left, 3 on the right. So this is why it is an unbalanced equation. So let's talk about balancing an equation. Okay. So in order to make an equation balanced, we have to add groups of the substances until we have exactly the same number of every element on both sides of the equation. So you notice that we have 2 N's on the left, and to get 2 N's on the right, I can't just add N because that's actually not in the reaction. There's no lone nitrogen atoms. I have to add an entire group of NH3. So now my nitrogen atoms are balanced because I have 2 nitrogen atoms on the left and I have 1, 2 on the right. But my hydrogen atoms are not balanced yet. So I have 6 on the right and only 2 on the left. So what I do is I add 2 more groups of hydrogen atoms to the left side in order to make it balanced. So what I have is I have 2 N atoms on the left in the reactant side and 2 N atoms on the right on the product side. I have 6 H atoms on the left in the reactant side, and I have 6 H atoms on the right. So this is a balance. This is a model for the balanced equation. So let's figure out how we add our coefficients in there, because our diagrams work out, but our equation is still not balanced. We have to add the coefficients in order to balance it. So the balanced equation, you guys take a look at this. I have 1 group of N2 and 3 groups of H2. And I have 2 groups of NH3 in the product side. So my balanced equation, I have 1 N2 plus 3 H2 makes 2 NH3s. Now, this, for those of you who have done balancing before, this will look a little funny because normally if there's a 1 coefficient, we don't write anything and 1 is understood. However, for my class, I'm absolutely fine if you want to keep that 1 in there, okay? So this is a balanced chemical equation, okay? So here we go. We're going to go over balancing a couple equations, all right?